recording now, and I'm going to start off by talking about this will be section 2.1, and this is two problems with one theme. It's about limits. And since we don't have a lot of time, I'm not going to go into a lot of theory, so make sure that you read your textbook and kind of understand some of the theory that's going on. I was just going to do a couple problems. So, for example, in the textbook, and we're using the Varburg textbook, problem 2.1, number 7, it says to consider this function f of x is equal to x squared plus 2, and then it's asking you to sketch the graph and draw the tangent line at the point 2 comma 6. So if we want to sketch this graph, we know that it's going to be the graph of x squared. So you know what the graph of x squared looks like. So that's x squared. And you can always go back. I'm recording this and I'll post these on, I'll give you guys a link to the YouTube channel. And then hopefully you got the link from Professor Stilevka because I sent it to her. And if you get that link once, I'm just going to keep posting the videos in there. So x squared plus 2 is just the graph of x squared shifted up 2 units. So let me draw that one then. So if we go up 2 units, our vertex is at 0, 2. And then they want us to look at the point 2 comma 6. So that means that when x is 2, our y value we know is 6. So 1, 2, 3, 4, 5, 6. So here's a point. Let me erase this function. I'll write it over here. Give me more room for this graph. All right, so that's what the function looks like if we graph it. And this is asking about a tangent line at this point 2 comma 6. So if I draw a tangent line in there, tangent line looks like this. And then we need to, so that's what we do for the first part, is just draw that tangent line. And the second part is asking us to calculate the slope through 2 comma 6 and 2.01 comma 2.01 squared plus 2. And then we got to find the slope of the tangent line. So if we want to find the slope of the secant line, how did I get that? Yeah, okay, so that's the line right there. So if we want to find the slope of the tangent line, we can use that definition. Slope of the tangent line is the limit as h goes to 0 of f of x plus h minus f of x divided by h. And that's, in this case, that's going to be equal to the limit as h goes to 0. Now what we're going to do is we're going to take this x plus h and we're just going to plug it into this function right here. So everywhere we see an x, we're just going to plug in x plus h. So we have x plus h squared plus 6. That's our function. And then we need to subtract f of x. Let me write it down here where I have a little bit more room. Limit as h goes to 0 of x plus h squared plus 6 minus our original function. So that's going to be minus x squared plus 6 divided by h. And then simplifying this thing, we get the limit as h goes to 0 of x squared plus 2xh plus h squared plus 6 minus x squared minus 6. And then dividing that by h, we can cancel the x squareds, we can cancel the plus 6 and minus 6, and then we're left with the limit as h goes to 0 of 2xh plus h squared divided by h. And then you can see that the numerator and denominator, everything has an h. So if we factor out an h, we have 2x plus h over h. The h's cancel, and then we're taking the limit of what's left. So the limit as h goes to 0 of 2x plus h. So we can plug the 0 in there for h. We're going to take that 0, plug it in here for h. and then this one's going to be equal to 2x. So we're saying that this is going to be the tangent line at that point, which I was drawing up above. But they're saying it's at the point 2 comma 6. At the point 2 comma 6. So that means that x is equal to 2. So that means that our slope of the tangent line is going to be 2 times 2, which is going to be 4. Right, so that's how you get the slope of the tangent line. I left the secant line out, which is part B, because I don't have a calculator. I kind of need a calculator for that one, but that one's a little bit easier, I think, to find that slope. You're just going to do the y2 minus y1 divided by x2 minus x1. All right, so any questions on that problem? All right, let's see. Are you okay then with using that definition of the tangent line? It's similar to what you did in college algebra where we were finding the difference quotient. The difference quotient was exactly this formula here, except we weren't finding the limit of it. So hopefully it's familiar to you and you've used that before. And if not, just do a few more practice problems. All right, then so that's section 2.1. Yeah, I was talking about the longer version, yeah. Okay. And then let's talk about the next section, section 2.2. So section 2.2 is the derivative. And you're going to see that the derivative, the notation that they use is exactly the same notation as we used in section 2.1, except now instead of x, they're calling it a c. So let's see if I can find something here. Some of these can get a little bit algebra heavy, so let's do one that has a bit of algebra. I'm not sure if you've tried these problems or not, but maybe I'll pick one where there's a little bit of algebra. So for example, if I'm going to do 2.2.19, 19 refers to the problem that's in your book. So for your homework, this is going to be problem number 5 in this section. 19 is the number from your textbook. All these problems come from your textbook. So this one is saying to use, I want to write the function. So for our function, let's say our function is f of x is equal to the square root of 7x. And this is asking us to use our definition of a derivative, which is f prime of x is equal to, same as what we did in the last section when we were finding the slope of the tangent line. So we're finding the slope of a tangent line. Here we're finding the derivative. We're going to see that those two things are the same thing, slope of a tangent line and the derivative. So we're going to do the exact same thing, just maybe a little bit different algebra here. So we're going to take x plus h and we're going to plug it into our function called f everywhere we see an x. So let's do that. We get limit as h goes to 0 of, and we have the square root of 7. I see an x, so here I'm going to plug in x plus h. So I see an x, I'm going to plug in x plus h. And then we have minus f of x. So instead of f of x, I'm going to write the square root of 7x. And then divide that thing by h. All right, so at this point, we know that we can't plug 0 in for h because we'd be dividing by 0. So we know that we can't do that. So we have to do something to this thing. So there's nothing that we can do to the denominator because it's just h. And so we'll look at that numerator trying to see if we can get rid of maybe get rid of those radicals in the numerator and try to get a common factor, of h so that we can cancel it with the h in the denominator. So we're going to multiply by the conjugate of this thing. So that means that we're going to multiply the top by the square root of 7 times x plus h. And then we're going to do plus, let me try and fix this, plus the square root of 7x. And then since we multiply the top by that conjugate, we have to multiply the bottom by that same conjugate, plus the square root of 7x. So this is the algebra that I was talking about. Some algebra we have to do. So this is a limit, and we don't want to forget that we're taking a limit here. So when we do this algebra, we're multiplying this thing by this thing. So looking at the numerators, we have to FOIL the numerator. So square root of 7 times x plus h times the square root of 7 times x plus h. So when you're multiplying, if you multiply the square root of x times the square root of x, it's just going to be square root of x squared. It's going to be equal to x. So the same kind of concept is going to apply here. We're going to have 7 times x plus h. And then we have a minus and a plus, since we're multiplying by conjugates. The inside term is always going to cancel with the outside term. Like if you take a plus b times a minus b, it ends up being a squared minus b squared, because those middle terms cancel out, that a, b, and minus a, b. So middle terms and the outside terms cancel, so we don't have to worry about them. And then the last term is going to be minus 7x. And then we're going to divide that whole thing by that denominator. I'm not going to do anything with that denominator. I'm just going to leave it as h times the square root of 7 times x plus h. I'm just copying it, plus the square root of 7x. Okay, so it's h times that. All right, then we can simplify that numerator a little bit. We're going to distribute 7x plus 7h. So I'll write that out, 7x plus 7h minus 7x. You can see that the 7x is going to cancel. And I'm just going to copy this again, square root of 7x. And that's equal to, there we go, the limit of 7h over h. And copy this mess again. Okay. And then we get what we were trying to, we see what we were trying to get in the beginning. We wanted to be able to find a common factor of h so that we can cancel the h out of the numerator and denominator and not have to worry about taking the limit when h goes to 0. So now we can take that limit because we're not dividing by 0. So the numerator is 7, the denominator is 7x plus h plus square root of 7x. So we can plug the 0 in then. So once we plug the 0 in, we don't have to take the limit anymore. We don't have to write limit. So in the denominator, we have the square root of 7x plus 0, h is 0, plus the square root of 7x. And that's going to be 7 divided by 2 times the square root of 7 times x. So that's going to be your answer then. That's the derivative of that function using that formal definition. All right, so any question about that one? And then do you want me to do another one from this section that has kind of a lot of algebra to it? Or do you want me to move on to another section? Doesn't matter to me. Another one from this section? All right. Oh, okay, now I see your comment there. Okay, yes, let's do another one with algebra, because sometimes the algebra can be the hardest part of these problems. So let's do, and then for some of this algebra, it's been a while since, if you're taking calculus, it might have been a while since you've done some of these problems with this much algebra. So this is going to be problem 2.225, And then this is problem number 7 in your homework. And they give us the function f of x is equal to 9x over x plus 8. And they are asking us to use the alternate form of the derivative in order to find this derivative. So the alternate form looks like this. The limit as t goes to x of f of t minus f of x divided by t minus x. All right, so this one's a little bit different. You end up with the same answer regardless of which way you do it. But now we're taking the limit as t goes to x instead of as h goes to 0. So we have the limit as t goes to x of f of t. So we're going to do what we did before. We're going to take our function f of x, and everywhere we see an x, we're going to input a t. So we have 9t over t plus 8. And then we have to subtract f of x. So I'm subtracting 9x over x plus 8. And then in the denominator, I'm just going to copy the t minus x. All right, now at this point, we can't take a limit yet because as t goes to x, if I plug x in there for t, the denominator is 0, so we know that we can't do that. So we have to do some algebra to it. So you can look at that numerator, and you can see that we have fractions up there. So it probably makes sense for us to just try and get rid of those fractions and maybe add those fractions that are in the numerator. So to get rid of, in order to clear the fractions, we have to multiply by the common denominator. So common denominator is going to be t plus 8 times x plus 8. So that's what we're going to multiply this numerator by. So if we multiply the numerator by that, we have to multiply the denominator by the same thing. So that's going to help us get rid of those fractions. So whether we were getting rid of the fractions or doing subtractions, the same thing. So limit as t goes to x. All right, now we're going to think about taking this whole thing right here and distributing it inside to each of these terms. So if I first distribute it to the first term, you can see that the t plus 8s are going to cancel each other out. So this is going to be a good problem to kind of do on your own because it gets a little tricky here. So we have 9t. So the t plus 8s cancel, and we're just left with the x plus 8. So we have 9t times x plus 8. So hopefully that makes sense. And if it doesn't make sense, just try distributing that t plus 8 and writing it next to that first term. All right, let's do the second term. Let's distribute the whole thing. We're distributing this whole thing now to this fraction. So when we distribute that whole thing, the x plus 8s are going to cancel. Now these x plus 8s cancel, and we're left with 9x times t plus 8. And that's going to be divided by that whole denominator. So I'm just going to write that. T plus 8 times x plus 8. Okay. And then if you want me to, at some point, just write that in a little bit more detail, I can do that as well. But I'm just going to continue with this problem and finish this. So, because this is the tricky part right here. This is the hard part. The rest of it is just distributing and just kind of straightforward. So then we have the limit as t goes to x. When I distribute that 9t, I get 9tx plus 72t. And when I distribute the 9x over here, I get minus 9tx, or xt, minus 72x, divided by t minus x times t plus 8 times x plus 8. So looking to see what kind of algebra we can do. We still can't plug that t. Still can't plug x in for t, get a 0 in the denominator, but we can cancel this term with this term. And what we have left is the limit as t goes to x of 72t minus 72x. And then I'm going to copy the denominator. So still can't do anything, still have 0 in the denominator. Still trying to do some more algebra until we get to a point where we can plug that x in for t. So you can see then in the numerator that we can factor that numerator. We can factor 72 out of the numerator. And when we do that, we get t minus x left over, which is a good thing because we're always looking for the common factor to factor out of the denominator. So we cancel those, and we are left with the limit as t goes to x of 72 over t plus 8 times x plus 8. All right, so now t is going to x. So that means when we see a t here, we can make that an x. And then we don't have a problem with any zeros in the denominator. So now we're taking that limit and we're going to plug x in everywhere we see a t. So we don't have to write limit anymore because we're taking the limit now. So we have 72 divided by x plus 8 times x plus 8, which we can just write as x plus 8 squared. All right, so hopefully that made sense, and hopefully if you were following me on that one, I really recommend that you just try to do that, probably that same problem again, and work that out and see if you can find the answer to that. There's one more question that I would like to do in this section because it's a little bit different. And that is going to be, so from your textbook, this one is problem 2.2.27, so it's problem number 27 in your textbook. And in your homework, it's problem 7. So it's a little bit different because they give us a limit in this case. So, all right. So they give us the limit. So what they give us is the limit as h goes to 0 of 2 times 5 plus h squared minus 5 plus h squared minus 2 times 5 squared divided by h. So they give us that limit, and they tell us that the given limit is a derivative, but of what function and at what point. So this is a derivative of what function at what point. So that's what we're being asked to find. So it's a little bit different. So what we know is that when we look at this thing that we're given, it kind of looks like our definition of a derivative, which talks about the limit as h goes to 0 of f of x plus h minus f of x divided by h. So it looks like that thing. And if we go and compare the function that we're given, the derivative that we're given, to this definition, we can see that where it says 5 plus h, that's going to be the x plus h. So 5 plus h is the same thing as x plus h. And we also see that this x and x is going to be equal to 5. So those are going to be in the same place. So x is going to be equal to 5. So we're just going to replace 5 with x in that initial limit that we were given. So we have the limit as h goes to 0 of 2 times x plus h squared minus 2 times x squared divided by h, since x is 5. All right, then, according to our formula, according to our definition, our formula for f prime of x is supposed to be this thing right here. So that's going to be our function. F of x is going to be our function 2x squared. And then where it says at what point, and then the point is going to be when x is equal to 5. So that's going to be the point, and that's going to be the function. All right. Any question on that? So that's going to probably be the end of section 2.2 for us. So any other questions on section 2.2? And then if not, we can move on to 2.3. Okay, perfect. So we will go to section 2.3. And we get another blank page here. Maybe. All right, so let's look at section 2.3. And this section is rules for finding derivatives. So rules of derivatives. So if you've taken a look at this section, I think probably most of the problems are going to be pretty straightforward. I don't think there's too much that we need to do. But you need to know how to use the power rule. You need to know the product rule and the quotient rule. So you need to know all of those rules. So I don't know if, have you done some of these problems, or do you want me to, are you okay with this section? Rules for finding derivatives. Product rule, quotient rule. I guess we could do one of each example really quick. So problem 2.3.23 says f prime of x, oops, not f prime, is y is equal to x times x to the 7th plus 5. So this one, in order to do this problem, you need to be able to recognize that this is a product of, oh no, I don't know what that was. Okay, there we go. So you have to recognize that this is a product of two things. It's a product of x and it's a product of x to the 7th plus 5. So you could use the product rule in order to do this problem, or you could just distribute that x inside the function. So if we distribute the x, we get x to the 8th plus 5x. And then if we want to take the derivative, I can just write y prime. The derivative of x to the 8th is going to be 8x to the 7th, and then the derivative of 5x is going to be 5. So that's going to be your answer for that one. For the next problem, which is 2.3.25, if you have a function y is equal to 6x plus 1 squared, we're going to learn how to do this in a second way in a couple sections. But for now, what you can do for this one is just FOIL this one. If you write it as 6x plus 1 times 6x plus 1, or you use a shortcut, and then just FOIL that thing. So you have y is equal to 36x squared plus 12x plus 1. And then it's easy to take the derivative and get 72x plus 12 as the derivative for that one. And then also we need to be able to use the quotient rule. So problem 2.3.38, if we have y is equal to 4x minus 8 divided by x minus 8, and we want to use the quotient rule, y prime. So if we have, let me think how I wrote let me look and look, I just want to look and see how your book writes here, the notation for the quotient rule. So I sent your formula sheet out, so hopefully if you haven't gotten the formula sheet, you can get that from or you can ask your professor about the formula sheet. because she might be doing it a little bit differently than me. So if you have a function where you have a numerator and denominator, you're going to take the bottom and you're going to multiply it by the derivative of the top. And then you're going to take the top function, f, and you're going to multiply it by the derivative of the bottom. And then you're going to divide everything by the denominator squared. So g squared. So that's what our quotient rule is. So for this function, 4x minus 8 divided by x minus 8, we're going to just write that bottom, which is x minus 8, and then we're going to multiply it by the derivative of the top. So the derivative of 4x minus 8 is just going to be 4. And then we're going to say minus the top, so we're going to copy 4x minus 8, and then multiply it by the derivative of the bottom. The derivative of x minus 8 is going to be 1. And then we're going to divide that by the denominator squared. And then we usually have a little bit of algebra to do at this point, so we can distribute the 4 into the denominator, and we have x minus 4x. So we have 4x minus 32 minus, and we're distributing a 1, so we don't have to do anything there, but now we have to distribute this minus 1. Inside here we have minus 4x plus 8 in the numerator. And then we're going to divide that by x minus 8 squared. So then in the numerator, these 4x's are going to cancel each other out. And then we have negative 24 divided by x minus 8 squared. So I think that's all that I'm going to do on this section, unless there's something else that you want me to do. So if there's something else you want me to do, let me know. Otherwise, I'll move on to the next section. All right. So that's 2.4. So 2.4 is, let me look at one. Okay. Yeah, let me know if you find something. So 2.4 then is derivatives of trigonometric functions. And a lot of this is using the same rules that we just had, and some of the trigonometric properties, as well as just our definitions of our trig functions. And if we have to come back to that one, I'm going to come back to that one, but I would like to go to section 2.5 and do a couple problems there. So let me look, see if I can find the problems here somewhere. All right, so I want to talk about section 2.5 because this section tends to be kind of the hardest section in this chapter. And this is the chain rule, and it's just so important. It's just really critical that you understand the chain rule. So the chain rule says that when you have two functions that are composed, when you have a composition of two functions, you have two functions f and you have a function g, and you're taking the derivative of them. So this is when, so I'll write it another way. We know that f composed with g means f of g of x, where g of x is an inside function and f is going to be an outside function. So when you have something that's set up that way, where you can see an inside function and an outside function, the way that we take the derivative is we take the derivative of f, that outside function, whatever that is, and we're going to evaluate it at the inside function. So we just are going to write that inside function. We're going to evaluate that. So that just means we're going to copy that inside function. So this is going to be f prime evaluated at g of x, and we're going to multiply that by the derivative of that inside function. So if we're going to think about that in words, this means the derivative of the outside evaluated at the inside means that we're just going to copy that inside function times, so we're going to multiply it by the derivative of the inside. So hopefully you've had a chance to try some of these problems. So for example, if you have this function f of x, and let's say that it's equal to 7 plus 4x cubed to the 6th power, you can see that there's two functions to this. We have this inside function. So the inside function, and I'll write it as g of x, is going to be 7 plus 4x to the 3rd power. And then the outside function, this is going to be the outside. The outside function is going to be something raised to the 6th power. So I'm still going to use x, but I'm just going to, instead of writing a different variable, I'm just going to call it x. It's going to be x to the 6th. So if we want to find this derivative, we want to find f prime of x using our formula up here. It says that it's going to be f prime of our inside function times g prime of x. All right, so the derivative of the outside. So we need to find the derivative of the outside function. So if we're finding the derivative of x to the 6th, we know this is 6x to the 5th, right? We bring the 6 to the front of the function, but we're not going to write it as x because x isn't our inside function right here. So we're going to evaluate this at the inside function, this g of x. That means that we're going to just copy the g of x, the inside function, which is 7 plus 4x cubed. And now we have to raise that to the 5th power. So that's what I mean by the derivative of the outside. Bring that 6 to the front, decrease the exponent by 1 at the inside. So you just copy that inside function. And then to do the second part here, we're going to multiply by the derivative of the inside. Derivative of the inside. So the derivative of this thing. So we're going to multiply by 12x squared. So then just simplifying this a little bit, we have 6 times 12x squared, and that's 72x squared times this 7 plus 4x cubed to the 5th power. And don't try and do anything else. You can't distribute that 72x squared, and you certainly don't want to simplify 7 plus 4x cubed to the 5th power. So that's going to be your answer. All right, any question about that concept of the chain rule? Does that make sense? All right, I'm going to do another problem then, and if you have any questions, just let me know. So let's say that we have function y, and let's say that y is x plus 8 over x plus 6 to the 7th power. So we want to find, take our derivative of that. So we can see in this one that we have, again, we have an inside function, and then this is this to the 7th power is going to be our outside function. So remember, we're finding f prime evaluated at g of x times the inside, derivative of the inside. All right, so we want to take the derivative of the outside first. So when we're finding our derivative of the outside, so we're going to bring that 7 to the front. We're going to bring it to the front, and we're just going to copy that inside, evaluate it at the inside function, and we're going to decrease the exponent by 1. So we have 7 times x plus 8 over x plus 6 to the 6th power. So that part should be pretty easy, right? Just kind of using our power. Oh, this is a problem. I just see your message here. This was a problem I was having problems with. Okay, good. So, yeah, I see other comments, for the most part it makes sense. The chain rule I know is really tricky, so I wanted to do a couple examples of it. So far we've taken the derivative of the outside and we've evaluated it at the inside, and then we want to multiply by the derivative of the inside. So we're going to look at the derivative of the inside. So the derivative of the inside uses a chain rule, so we have to kind of do that off to the side and then plug that thing back in. So if our function right now, instead of calling it y, now I'm going to call it g of x. I'm just looking at that inside function, x plus 8 over x plus 6. Because I need to take the derivative of it so that I can plug it back in here. So in order to take the derivative of this, I need to use the quotient rule. So I need to use the quotient rule. So remember from the quotient rule, we have the bottom. So the quotient rule says we're going to take the bottom and we're going to multiply it by the derivative of the top, which is 1. And then we're going to say minus the top, let's copy that, times the derivative of the bottom. The derivative of x plus 6 is 1. And we're going to divide that by x plus 6 squared. You certainly don't have to write those ones out. All right, let's simplify this. So this takes a little bit of algebra here, not too much. So we have x plus 6 minus this whole thing, minus the x plus 8. So it's minus x minus 8 in the top divided by x plus 6 squared. All right, and then that is going to be equal to the x's cancel. So in the numerator we have -2. And then in the denominator we have x plus 6 squared. Okay. So that's the derivative of our inside function of g. But that's not the question that we are asked because we have to find the derivative of the function y. So all we're going to do is plug that thing back in there for g prime of x, because that's what we just found here. That was just the derivative of the inside. So the derivative of y prime, is 7 times, I'm just copying what we did before, x plus 6 to the 6th power times this -2 over x plus 6 squared. And then simplifying this a little bit, you can, for this part here, you can separate that numerator and denominator, so it might make it a little easier to see. You don't necessarily have to show this step, but I just want you to see, that should be 8, that this is x plus 8 to the 6th power divided by x plus 6 to the 6th power times this -2 over x plus 6 to the 2nd power. All right, let's take a look at the numerators. I can think about that 7 as being 7 over 1. And this is the derivative. So y prime is going to be equal to -14 times x plus 8 to the 6th power divided by, and now we have x plus 6 to the 6th times x plus 6 to the 2nd power, and when the bases are the same, you can add the exponents. Like if you have x to the 6th times x squared, that's x to the 8th power. So when the bases are the same, you can add the exponents. So x plus 6 to the 8th power. And then that's going to be your answer for that one. All right, so hopefully I answered your question on the chain rule. And then there's another one with trigonometry that I wanted to do. Since it's a little bit different and we haven't done trigonometry. So this is problem 2.5.27, which is going to be problem number 9 in your homework. And this function is negative cosine of x over 1 plus the sine of x. And then that thing is squared. All right, so if we want to find the derivative, we're going to start in our usual way. So f prime of x, we're going to take the derivative of the outside function, which is that function, something being squared. So we're going to bring the 2 to the front and just copy that inside function. And that's going to be to the 1st power then. And so that's the derivative of the outside at the inside times the derivative of the inside. So we have to multiply that by the derivative. And I'm just going to use different notation here. d dx just means the derivative of negative cosine of x divided by 1 plus sine of x. Right, then we end up in that same position where we were in before, where we have to take a derivative of a quotient. So we really need to use the quotient rule. And again, do this one off to the side. d dx of negative cosine of x divided by 1 plus sine of x. All right, so just like before, using that quotient rule, the quotient rule says the bottom, so we're going to take the bottom function and just copy it. So 1 plus the sine of x times the derivative of the top. So remember the derivative of cosine, so d dx of cosine of x is minus sine of x. So that's from the last section. So minus cosine of x, the derivative of that, is going to be minus the opposite of sine of x. So it's just going to be the sine of x. Okay, so derivative of cosine is going to be minus sine, so minus cosine, derivative of minus cosine of x is going to be sine of x. So that's the bottom times the derivative of the top minus the top function, which is minus cosine of x, times the derivative of the bottom. So the derivative of 1 plus sine of x, derivative of 1 is 0, so derivative of sine is going to be cosine of x. And then we're going to divide that by the denominator squared. All right, so hopefully that's okay so far. And trying to simplify that numerator, we can distribute that sign here, and we have sine of x plus sine squared of x. And then this is going to be a minus times a minus. It's going to be plus cosine squared of x divided by 1 plus sine of x squared. All right, then if we look at the numerator, we see that we have the sine squared of x plus cosine squared of x. And this is the Pythagorean theorem from trigonometry that says that sine squared of x plus cosine squared of x is equal to 1. So we're going to use that here. So in the numerator, we have sine of x plus 1. And then the denominator, just keep as 1 plus sine of x. Well, I put the square in the wrong place here. Let me fix that. That needs to be on the outside of the parentheses. 1 plus sine of x squared. So if you put that on the inside, if you're writing this, make sure you have that on the outside where it belongs. All right, and then 1 plus sine of x divided by 1 plus sine of x squared. You can cancel one of those, so that's equal to 1 over 1 plus sine of x. So that is just the derivative of the inside, that g prime of x. So that's our g prime of x, derivative of the inside. So we have to do the same thing that we did before. We have to take this thing, go back up here, and plug it in where we said we were taking that derivative. So our f prime of x is equal to 2 times negative cosine of x divided by 1 plus sine of x times 1 over 1 plus sine of x. And then simplifying this, we're going to get negative 2 cosine of x divided by 1 plus sine of x, and that thing is squared. And that's all you can do with that, so that will be your answer for that problem. All right, any questions on that? All right, so that's going to be the end of section 2.5. I'm going to stop it now. The very last thing that we had is section 2.6, which is higher order derivatives. And this section is about finding second derivatives and third derivatives. And in general, they're pretty straightforward. They are, like if you're finding a second derivative, you just take the derivative of the first derivative. And if you're finding the third derivative, take the derivative of the second derivative. So those are pretty straightforward. We can talk a little bit about velocity and acceleration probably on the next time that I meet, if you have questions about that, or if anybody else has questions about it. But I'm going to pause this now and then end it at this point.